I love this question. Hummingbirds seem fragile, but their wings capable of forces and accelerations that are crazy. So you want to find what is the maximum acceleration of the wingtip of a hummingbird. So the master equation is A, or for the acceleration max, it's a master equation, equals 2 pi f squared a. So we have to get from the graph, we've got to get a and f. 2 pi, of course, we know. So a is, now this is y, all right, so what is the biggest they can get. Now note that the units here are in millimeters, so it's important that you convert the millimeters, right? It's 40, right? I'll say, right? A is 40 millimeters. It's obvious, I think. So you have to convert that to meters and then put that in A. And then the time, the beating of the wings, what's easy to calculate or to garner from the graph here is the period. So for the period, I would start, I like to like it for like some nice round numbers where it crosses the axis. And so right here we've got a 0, and to go through one cycle it goes down and up, and so right here it's gone through one cycle. So I think you can figure out what is its period, but remember period or frequency is 1 over the period. But watch that this time unit is not, I'm sorry, I made a mistake when I was in the problem. It's not in seconds, but in milliseconds. Okay, and so that's going to give you the frequency, and then once you do that, you can find the acceleration. It's a big number, which you would expect because kind of they hint at it. They said they're capable of significant accelerations. And then for part B, if you will, it says and in units of g. So when you say and in units of g, what that means is, let's say you have an acceleration of 800 meters per second squared. That's, depends on what numbers you might be given. You just divide by 9.8. And what we say, it's so many g's, right? So 800 divided by 10, that'd be about, 9.8 is exactly 10, but it is close enough. That would be 8g. So 8 times the acceleration of gravity, or if that's not the answer. But it is probably ballpark what you're going to get. So, hey, you seem to have a problem.